All right, so 6.2, we still have more to do with our discrete random variables or more random variables. The first half of this you might look familiar from another chapter previously. I think it was chapter 2, but anyway, it's a good review. Anyway, if you forgot, right? So the first half of this section, we're going to spend transforming random variables, right? So that was, if you remember from before, that's where we added, subtracted, multiplied, or divided by a constant to all of the x's, or all of the values within the distribution, right? So we would do the same thing here. So I actually have to start us with an example, okay? And this was an example. The title was Pete's Jeep Tours. All right, and this dealt with how much money that he collected, with probabilities listed for how much money he collected for each day. So what we can do, right, is we can enter everything. I already have everything entered into my L1 and L2, right? So there's my L1s, which is all the total money collected. All of my L2, that's all of the individual probabilities, right? And what we can do is we can find a mean and a standard deviation of our money collected, right? So calc, one var stats, L1, frequency list is L2, calculate, and we have a mean of 562.50, and standard deviation we have 163.4, we'll round it to 46, okay? And then we can see we already have the histogram there, right? We can say that this is approximately symmetric, right, with a single peak, right? And then we got your shape, we got your center, we got your spread, right? That's of the original data, right? So why do I bring that up, right? Because if we were to transform this is the money he collected, right? But say it costs him $100 to buy permits, gas, and a pass each day for the trip, right? So we're going to create a new distribution, right? We'll call V, would be the amount of money that he's basically profit, right? Profit for Pete. Okay. So you have your total profit, right, which is V, and then you have your probability, right, of each one. So what you'll notice is instead of $300, right, this would be 200, and that would be 0.15. Instead of 450, right, it'll be 350, 0.25. Instead of 600, it should be 500, 0.35. Instead of 750, it's 650, 0.20. Instead of 900, it would be 800, right, and that would stay as 0.05. Okay, so you have your, if we were to enter those, right? So each of these 200, 350, 500, 650, and if you remember back, if we added or subtracted, right, same thing with either one, it's just adding or subtracting to each of my x's, right? Do you remember what happened to the mean, standard deviations, all that stuff, right? What values changed? So if we run this again, right, we end up with a mean profit of 462.50, and we would have a standard deviation of 163.46, right? So if we compare those to what we had, right, the standard deviations are identical, right, and the means, right, the new mean, the profit mean, is $100 less than the original, right? And that's because the new distribution, since you're subtracting 100 from each of the money collected, right, your average is going to be $100 smaller. All right, so to kind of put this into perspective, right, if you are adding or subtracting, kind of generalize this a little bit, a constant, right, on a probability distribution, Okay, there's going to be, so this would be adding and subtracting, then we'll do the multiplication and division, right? But if you add or subtract, right, adding or subtracting the same positive number, we'll call it A, to each value or from each value of a random variable, right? Here's what's going to happen, right? It's going to add A, or subtracts to measures of center, right, and location, right? So in other words, your mean, your median, your quartiles, right? The individual values themselves you're going to add, to each of those. However, right, so here's bullet number 1, bullet number 2. It does not change measures of variability, right, which that would be range, right, IQR, standard deviation, right, etc. And thirdly, it does not change the shape of the distribution, right? So if this was skewed right to begin with, it's going to be continued to be skewed right. All right, so it adds or subtracts to the actual values of center and location. The mean, median, quartiles doesn't change anything with variability, and it doesn't change the shape. Okay, so for example number 2, we've got, right, a large corporation. You have it's skewed to the right, right? So there's my shape of my original mean of 68,000, standard deviation of 18,000. He wants to give everyone a $5,000 bonus, right? So that's just a straight up plus $5,000. So X is the current salary before the bonus. Y is the salary after the bonus. So describe the shape, the center, and the spread, or variability. So the shape, since this was skewed to the right, this is also going to be skewed right. Center, right? So the mean of Y, right, is going to be the old mean, right, which was X plus another 5,000. So it'd just be the mean of X plus your $5,000 raise, which 68,000 plus 5,000, right? It's going to give us 73,000 is the mean, and the spread or the variability, right? That number, since it's going to be equal, right? Because you're just adding 5,000, so that's not going to change the variability. So it's going to equal the old standard deviation, which is 18,000. Okay, so there is your addition and subtraction, right? It's going to be those. And then in the second part, we're actually going to at least write this down. So we have, that's the effect of adding or subtracting a constant. We are going to look at the effect of multiplying or dividing by a constant on a probability distribution. Okay, so we will get into that in part 2.